Ladies and gentlemen, thank you very much for turning up today for the start of a very, very different 2020 GSE conference. As most of you know, I've probably met most of you before. My name's Mark Wilson. I'm the GSE UK conference manager. Work for BMC for my day job, along with the rest of the GSE team. We do this as a bunch of volunteers. So thanks for bearing with us as we've put our very first virtual conference together. I'm going to run through a few slides just explaining some of the differences we've got to the conference this year, and then we're going to start off the conference today with a keynote from a very good friend of ours, a very good friend of mine, Mark Anzani from IBM, and I'm going to be a look back at Mark's 38 years in IBM. I keep telling him he doesn't look old enough, but he keeps telling me I'm full of something, but I won't go there. So get through that. So that's our start for today. And then the real meat of the conference, as we talk about this, is obviously into Tuesday, Wednesday, Thursday. So, yeah, welcome. And as I said, thank you for coming. It's a little different. It's the first time we've ever done anything as big as this, as an online virtual event, for all the reasons we're all very aware of. So yeah, it is a little different this year. We've tried our best to make this as fun and as interactive as we possibly can. We've had a fabulous support from all of the speakers, all of the GSE team, and all of the vendors, sponsors for us, and we'll get onto that as we go through. As I mentioned, the main technical agenda is going to run Tuesday, Wednesday, Thursday this week, and Tuesday, Wednesday, Thursday next week. So we've split it over a 2-week period. We've got about 155 sessions, 160 sessions running, with keynotes interspersed throughout. If you're looking at the agenda and you're looking at times, as it says here, all the times are GMT. Okay, we have had a couple of questions about that, so all GMT at the moment. I do appreciate for various folks, especially those on the west coast of North America, it's very early, or as Mark and I were talking about earlier, this is a lovely time to be starting if you're on the east coast around about 9 o'clock in the morning. So we're doing all of our social media stuff. As usual, we've got the traditional hashtag GSEConf. We are going to run the social media competition right through to the end of the conference until the 12th of November. And the plan is, should we ever be able to meet together again, the winners will get free passes to the conference in 2021 in Cardiff at that lovely hotel that we should have been at now, enjoying a face-to-face meeting all together. And I'm really saddened that we're not there, but hey, we're going to make the most of it. This is going to be a fabulous couple of weeks. So the app is back. We've got the Attendify app, and you need to download it from the Apple Store or Google Play. Search for GSE, select the 2020 conference, and the password is virtual. The code is case sensitive. You need a capital V for Victor at the start, virtual. Okay. Again, let us know if there are any issues. It's got a messaging facility in there. Any bugs or suggestions for improvements, please let us know. As is always with the conference, I'm absolutely blown away by all of the support that we get from all of the vendors, and every single vendor helps us and supports GSE fabulously, and what this allowed us to do is to invest in the platform that we're going to use for the duration of the conference, hire some professionals who know how to put these things together, which is always useful. As speakers and chair people, we've had training from the third party who are helping us. So Joe and the Sheer Edge team and Gino from Blue Tokyo, fabulous support, and thank you very much for that. And again, thank you to all of the vendors for all of their fabulous support for this, from IBM to BMC, ASG, Red Hat. You can see them all here. Broadcom sponsoring a total track. So it's, yeah, fabulous support, and thank you very, very much for all that support. We've got 2 quiz nights sponsored by Macro 4. One Tuesday, as in tomorrow, and one the following Tuesday. There will be a link for you to register. You need to register 30-60 minutes before the quiz, because it's a platform that's used on a regular basis. So if you go there now, you will actually see the results from last Monday's quiz. If you go tomorrow morning, you'll see the results from the quiz that's tonight. Nothing to do with GSE. It's an online platform that's used. It'll all be cleared out about 60 minutes before we start on Tuesday the 3rd, and the same on Tuesday the 10th. There are some clear instructions out there on what to do and how to use it. So it's just a little bit of fun. Looking forward to that. So feedback. You will notice feedback has gone all online. We're not using paper this year for some reason. I'm not too sure why we're not using paper, but it's all online. You'll also notice that the session codes have gone to 3 characters. That's because we've got so many sessions and we needed a stream code in there. So all the session codes are there. Please, I would encourage you all to feedback on every single session you attend, because that helps us understand and rate the session, so we know exactly what's going on. There's a QR code at the start or the end of each session, so you can just scan the QR code and it will take you directly to the feedback page for that session. We're going to record all the sessions, including this one. So every single session will be recorded. We're going to load them all onto a Vimeo site as part of the package we've got for the virtual conference. And the details will be provided just shortly after the conference. All the attendees, all the speakers will all get a link to say that they're there. We plan to keep the material closed to the attendees for 2 or 3 months. And then we will port it to the GSE YouTube channel, where it will become freely available to anybody, whether you attended or not. Okay, so that's what we're going to do. Mention there's the GSE YouTube channel for all of the previous videos there. So there's still quite a lot of very, very relevant and useful information there as well. We've got the traditional technical agenda, and it's got the chilies on them. Okay, the more chilies, the more technical. So no chilies, non-technical, 4 chilies or 3 chilies, very, very technical, just so you can pick and choose and make certain you pick up the session that you want. You'll see our little professor friend here, and we do need to get a much better graphic for him than we have. But basically, the little fellow here indicates on the agenda that the handouts have been uploaded. We will encourage all of the presenters to upload their presentations in PDF format, so you'll be able to pull them down, and you'll use your email address and password you've got for where you've built your own agenda and all that to be able to do them. Every year, Best Speaker Awards, and this is becoming a little boring now, because there's one individual I think we're going to have to ban from coming to the conference. So we're going to award one of the speakers a Distinguished Speaker Award, so we can never ever claim a Best Speaker Award, but you know what's coming. So Best Speaker Prize is based on session feedback for a vendor and user. So we always recognise the folks at the closing session, and there are still a few of us hanging around. But we are very conscious that not everybody's there. So by way of recognition, the best vendor speaker went to Mark Nelson for his session at Whittlebury in 2019. Again, another fabulous session for Mark. This is the last one he's going to win. I can guarantee it. Okay, because I'm going to change the rules. So, but that's, yeah, just so Mark knows, that's all. I'm not bitter. I'm not twisted. But so Mark, well done again. Thank you very much for everything you do for GSE. And looking at the stats for what sessions people have chosen, there's a good chance Mark might be in the running for this year as well, because for his mainframes and the moon presentation, there's over 120 people registered for it already, or have selected it in their BYOA agenda. the best user speaker, and this gives me a really, really nice, warm feeling, because the winner was Christian Karachi from Bedford University, and Christian's done a ton of work in and around computer forensics and talks passionately in the security stream, and he's a lovely guy, and it's well deserved and fabulous. But yeah, a virtual round of applause to both of you, and thank you very much. And again, thank you for your support. And both are presenting this year, so again, brilliant. Always difficult, this part. How do you say thank you to so many? But the team that puts the event on for us is a large team, and yeah, put an immense amount of work in this year. Can't name them all, but I'll name a few. James, Neil, Steve and Kira for all the work on the agenda and the app and all the other stuff. The social media team, Angie and Caroline, fabulous work getting all that out there. The conference planning committee, we have some very productive sessions once a month for an hour to put the event on, and they've worked really well. All the chair folks for organising the agenda. It's a lot of work, and I know we nag, but we really are thankful. And Intermesh for building all the website and all the tech that goes behind it. So yeah, really thank you for all of that. Sort of coming towards the end of my piece here now. Last year, we had two charities, Bernardo's and Mencap, and each one of them received £2,361. I've actually got the cheques here. They're nice big printed ones that we have yet to use because, unfortunately, we went into lockdown before we were able to use them. This year's charity, surprise, is an NHS-based one, NHS Charities Together. We've teamed up with Virgin Money Giving to give us the platform collecting that. We're asking if you attend a session, a little donation of 50 pence or £1 or anything else, just to say, thanks to GSE, so we can then donate that on. Obviously, greater amounts are more than welcome. Anything above £100, and we'll recognise you on social media and say thank you very kindly. But yeah, please support the charity. These folks do such great work for us all, and especially in these very trying times. So it now gives me great pleasure to hand over to Mark Anzani. So Mark's going to do a presentation on a look back at 38 years in IBM. So I just have to stop sharing my screen as I do that. So I'm going to carry on talking while I stop sharing and then allow Mark to get set up. But a fabulous guy, and I'm really looking forward to this, Mark. So Mark, over to you to share your screen, and I'm going to hand over to you. Thank you.
Okay. Thank you, Mark, and hi to everybody in these strange circumstances that we find ourselves. I, like Mark, was very much looking forward to this year's conference, particularly because of it being at the Celtic Manor in Newport, not Cardiff, Mark, Newport, which, it's about 20 miles from where I grew up. So I had all these stories and things I was going to get people to do, and here we are virtual. So with that, it is really great to have a chance to chat to everybody, just to make sure that the mood was correct for a GSE event. I hope all of you stayed up very late last night drinking somewhere, just so you had that right feeling in your head as you come together in this gathering, because it wouldn't be a GSE without a hangover. So with that, I chatted to Mark a number of months ago, maybe even last year, the end of last year, about this year, about the conference. And as you move on in a career, and particularly with the period of time that we're in right now, with COVID and pandemics, you have a lot of time to reflect. And I've been, thinking at periods about the time that I've spent in IBM, but not just my time in IBM, the things that have happened associated with the platform that we love so much. That's the heart of this conference. And I thought I'd share a few stories about the platform. Everyone really, I imagine, well, most on here will know a great deal about the history of the platform. But I thought I'd share a few stories, things I've come across and done through the career that I've had, to give a little bit of a personal twist to some of the events that happened there. There are some personal stories, and I'll throw a few photographs in as we go along the way. Photographs of the systems and photographs involving myself, so you can see how the whole progression of things have gone. It might seem a little bit like bragging at times. I don't mean it to be like that. That's really not my personality, for those of you who know me. But sometimes I do feel that these personalized stories are a little bit more fun and a little bit more memorable. Final disclaimer, I started my career as a hardware person. While I'm involved with hardware and software and the whole host of technologies there, my roots are back in hardware, and that's sort of the predominant theme I use just to illustrate the story for us today. So with that, why are you not? There we go. So with that, 38 years. In 1983, the processing platform, from a hardware standpoint, that we were, had placed out into the marketplace, the highest form of that was the 3084, which I'm sure many of you remember, which, as you can see, this really large piece of machinery that fills a room, consisting of 4 central processors and 64 megabytes of main memory. Thermal conduction module implementations, lots of pin-through-hole card technologies, a host of software involved with it. If you wanted to send one of these out to a client, it could often take 2 tractor trailers or articulated lorries, for those who go in the UK, in order to be able to haul it to the client's location, and all the time it takes to set up. And when I walked into IBM and saw the test floors that this was on, first of all in the Poughkeepsie area, and then subsequently when we moved the whole operation up to Kingston, New York, because it was right at the connection points of 2 major highways, it was just such a stunning physical and visual sight to see literally acres of raised floor space with all of these systems on there. I mean, today, with the systems of today, it's still an amazing sight to see the test floor in Poughkeepsie, but it's just nowhere near the acreage that we had here. With these systems, in the fourth quarter, in the old days, they used to say to employees, kind of stay off the roads around the Kingston facility in the last few days of December, because we had about 147 tractor trailers rolling out on an annual basis, on a daily basis. For that. So that was quite a bit of traffic. And now, of course, over that 38 years, the nature of technology, the progression, the investment, the innovation, in every aspect of it, not just the hardware, but the operating systems and the maturity and the way in which the whole stack has come together from an IBM software product standpoint, from the ecosystem, from our partners, everyone out there working with this technology to produce something that is such an elegant piece of technology in the Z15, with its much higher processor counts and memory, but so much more. The cloud capabilities, the security capabilities. All about this, but it's just amazing to think, even though 38 years may seem like a long time to some that are on this session, it just goes in relative blink of an eye. Now, not everything advances or matures as well during a period like this. There is 38 years of decline involved here. Oh yes, people, this is what I once looked at. For those of you having difficulty, I'm the one on the right-hand side in the suit. This was me just before the beginning of my career with my good wife, still my good wife. And then, decline sets in, and a few months into the pandemic, my wife really had to have a conversation with me about what the hell is going on with your face, Mark. So we've cleaned her up a little bit, not completely, but there's something where the 38 years is quite a bit more evident. I did not need to show a photograph of Holly here, because she, of course, during this period has not changed one bit. Now, what was going on in 1983? So, Margaret, some of these facts may not be completely correct. They may prove to be factoids, but hey, you Google it, it tells you it. It's got to be true, right? So Margaret Thatcher came in with a landslide victory, as many will remember. One of my favorite shows when I was out growing up is MASH, and it was its final episode. Microsoft Word, the Swatch, and this was from the Brinks robbery at Heathrow, netting $37.5 million worth of gold bullion. And then when I put the next bullet, Mark Anzani has found a job. I actually didn't realize the link to the Brinks robbery. I assure you I was not involved in that in any way, shape, or form. I found some uncontroversial employment, should we say. The IBM of that time, when I joined the company, John Opel, as a CEO, became the chairman of the board, and there was a triumvirate, a threesome that was really running the situation here. John Akers as the president, who would then become the CEO somewhat later, and Paul Rizzo rounding that out as the vice chairman. As you can see from the statistics, back when I joined, it was a very large company, a worldwide company. Revenues that were growing quite rapidly, earnings growing quite rapidly, all saw public information from the IBM archive site. And it was in this period that the plans were in place, and the view was for a very rapid rise of IBM to become a $100 billion company. That's the sort of environment in which you were in. So in Poughkeepsie, for example, in any given week, there were 100 or more people coming in, engineers, young folk coming out of college, being interviewed for positions. I remember staying in, they were putting us up in all sorts of places all around Poughkeepsie, places that don't even exist anymore. I ended up in a motel on Route 55, Binder's Motel it was called, and it really struck me. Left quite an impression, because there was a coin slot on the side of the bed in the room that I stayed in, where you could put quarters in and the bed would vibrate. So I'm not sure exactly what was going on at that hotel when IBM was not sending new recruits there. But I have to admit, it was, quite a revelation to a young lad coming out of a background in Wales to see something of that type, I'll have you know. Product-wise, the PC had been out and announced, but the PC XT was introduced that year, as well as System 36 and the 4361, 4381 extensions added to the 4300 line. And as I was doing the research, our database products, one of them was renamed and introduced and technology upgraded to become the DB2 that we know and love today. We started really hitting our stride in terms of patents within IBM in this period. And I can't remember exactly what year it was now when we moved to the largest number of patents awarded in the world, a little subsequent to this, but we have not relinquished that. And a lot of that falls to the innovations of our engineers and our teams, but also to IBM research. And one of the amazing things that was produced in '83 was the scanning tunneling microscopy, the ability to actually view and be able to see atomic level detail in structures. And then finally, the final comment I wanted to make on this is, at the time, as opposed to today, where there's a huge network of manufacturers and providers, where technology and chips and circuit boards made, manufactured, and we tend to absorb them at a manufactured subassembly level and put them into our systems, married with the complex custom logic that we design ourselves. Back in this time period, a huge amount of this we were doing ourselves. Very detailed power supply designs. We were manufacturing the memory and logic cards ourselves within IBM, the logic card assembly and card plants in building 2 and 3 in Poughkeepsie was where I ended up in starting my career. And we were expanding rapidly because in 1983, our current hardware product line was the 3080X family. We had produced, as mentioned, the 3084, this honking machine, huge machine of 4 processors and 64 megs of memory. But everyone was working very aggressively on the hardware and the software associated with the exploitation of what would become the 3090, scheduled for delivery in 1985. Had the trends of more power, more memory over the 3080X line, and was also a place where vector facilities introduced for the first time, a thermal conduction module implementation of a mathematical, vector processing unit. And as a part of the 3090 and its complexity, there was a huge upgrade in the amount of system monitoring, the amount of precise timing and distributed oscillators throughout this system, which resulted in a great deal of analog electronic content over and above what had been used previously, predominantly, a digital world. And IBM's capabilities at the time within its manufacturing, engineering, test organizations around logic cards was really focused on digital. And there was not a great deal of experience in the analog world. So they went out to look for and hire folks that had experience in analog electronics. And when I left University of Bath in England, I worked for 2 years for Plessey Semiconductors, for those of you who may remember that company. And where I worked in Swindon, we were doing a lot of work on high frequency dividers for TV tuner applications, a lot of remote control work and analog sensing, along with controlling electronic equipment. So I had experience in development and test of analog subassemblies, and that's what got me my job in IBM. And it was to be the person building the hardware, test facilities, and writing the code on a Hewlett-Packard 3060A board test system, later became the 3065. And what it was fundamentally a set of lab equipment, IEEE bus controlled, with a Hewlett-Packard PC and a set of programming software we would write to be able to do that. And it was quite a blast writing all that thing to get the analog componentry tested of the 3090 so we could launch that. I then moved on and was able to observe, one example I wanted to illustrate of IBM's investment in technology leadership that we've continued through the decades. One of the notable stories that, I was involved in was memory technology, DRAM technology. Rather than today where it comes from a small set of providers out in the world, folks like Samsung. Back in the day, IBM was designing and developing its own DRAM technology, static RAM technology as well. Our facilities in Burlington, Vermont is where we had the focus on memory. Our logic, our high-speed custom bipolar logic, that was focused down in Fishkill. And IBM, with research, developed the first experimental 1 megabit chip, the Eagle project. And in 1986, it was brought to us to begin to use it in the expanded storage subsystem that was present in the 3090 system. And many of you may recall that back in that time, the main memory, the card-based design for main memory, was a different physical entity then the expanded paging storage implementation, a different set of memory cards there. The expanded storage had more error correction associated with it. That affected speed. The expanded storage was slower. That was fine for it. But because we had triple error detect, double error correct, we were able to use more leading edge memory technologies, because if there were bit or line fails, we could mask them and no one would even know that. And this on the left there is one of those first implementations using the 1 megabit chips. This was the largest expanded storage array card we made at the time, 16 megabytes. And I'm really showing it for folks who are part of this conference that may be a little bit younger than I, just so you can get a look at some of the things that we used to do with this pin through hole technology that was manufactured within IBM facilities, tested within IBM facilities, and just a few of the components came from outside. The logic was ours, everything. The little red dots on it indicate that this one has some chips to be replaced from our test process, and just sites like that take me back. On the right, of course, is you can see what the dress code was in IBM at the time. In the past 6 months, I think this is the first time I put a collared shirt on, so it is quite fun to see how everyone had the suit and tie on back in that day. Now, one of the things that was cool about this experience, and was cool about having leading edge technology of this type being deployed in the 3090 system, was we got to send one of our expanded storage array cards into orbit. And I thought about this point when I saw Mark Nelson's upcoming keynote scheduled for, the discussion about IBM and the mainframe and the moon. We had started working on a follow-on design using a 4 megabit memory chip, Gazelle, as I recall. And also IBM had a partnership with the supercomputing center at Cornell University up in Ithaca, New York. And a part of that supercomputing complex, they actually used 3090 as a vector processing facility for that. And a lot of it was the amount of memory that we could put into play in a 3090 system really helped get some of the data processing in connection with some of the true supercomputing environments that they had. Now, a graduate of Cornell, G. David Lowe, was a mission specialist with NASA and was scheduled to go up on the 33rd flight of Columbia. And what I did not know at the time is each astronaut can actually they have a locker where they can take a certain weight of personal effects themselves. And one of the places he went to for effects, because of his close association with his alma mater, was to go to Cornell. And they decided on a mix of things to send up. But one of the things they really wanted to do, because it coincided with a lot of work they were doing and proud of, making announcements around the supercomputing center, was they wanted to send a component of that supercomputing infrastructure up on the space shuttle. And they chose the expanded storage array card. So I shipped that up to them. David Lowe took that up on Columbia on the flight, and it ran around the Earth 172 times, as you can see from the certificate that they handed to us after it was returned. I went up and he presented the card back to me, and then we put it into the museum, the technology museum that Cornell had up there. Additionally, just for interest, he also took up a pair of Ezra Cornell socks, and Ezra Cornell is the person who founded Cornell University. So he really had the old with the new in this environment. But a nice little story from my standpoint. But most importantly, we were able to do something like this because of the technology investment that IBM was making at this time in pushing memory forward. And it's just indicative of the way in which IBM's investment and the way in which the Z platform is really able to leverage that to stay modern and fresh. So then, as we move on into the 90s, these points that are coming through over on the right-hand side here, you can read through these moments in history. But one that had such a major effect, it was not the sole effect, but a major effect within the development of this platform we love, was the recession that was going on as we left the 80s and went into the 90s. IBM, from that standpoint, Akers had come and moved up to the chairman and CEO position. We were growing the revenue numbers. You can see from 40-something billion 10 years ago up to almost 70 billion at this time. Employee growth. You wouldn't necessarily think that that was the vector where trouble was on the horizon. We announced the risk systems risk 6000, and new versions of the personal computers. Some of you may remember the Prodigy service, where IBM teamed up with Sears Roebuck on this this email, internet information Prodigy sort of service, and that became generally available. I got my PC and I got that and had my 1200 baud modem and was having all sorts of fun with that. And back to when I came in 83, IBM Research was now using scanning tunneling microscopy to actually move atoms around. And there was the famous image they had in the New York Times, I believe I first saw it, when they moved atoms around to create the IBM logo out of atoms. So a lot of cool things that were going on, things looking good. We, at the time, had the System 390. We announced that architecture point, the ES9000 line of processors. And we were, advancing the speed, advancing the density through the use of bipolar technology, running it faster, running it hotter, leveraging our thermal conduction module technology. Dick Chu, an IBM fellow, so many different patents around cooling, such an industry leader in that, to create this technology. And, one of these TCMs didn't contain a certain number of processors. One of these thermal conduction modules contained a piece of a processor. So you needed anywhere from 6 to 9 of these on a huge board in order to be able to make a processor, and then you had a host of other things around it, duplication of the processors, etc. Each of these thermal conduction modules, they were starting to get up to about 2,500 watts because of the power that was required for that bipolar capability. The technology itself, the smaller you make it, the more the leakage is, the higher the power goes up. 2,500 watts is like, a toaster oven. So bipolar was only had a certain amount of life left in it. And also mid-range PC technologies, the economics of what was going on with the recession was putting huge pressures on the economics and the margins of computing. And the mainframe was under considerable attack because of the environment there at the time. And it was very expensive for us to be able to make this because it required more and more investment into a technology, a bipolar technology, that was unique and highly customized for us. And when I say us, I mean what was the System 390 business at the time, the IBM Z business, if you will. We were the only users of this. And it was billions of investment in infrastructure to make this technology. So something had to give. Something really had to give. And it's a well-told and well-known story. There have been many industry studies on it. But we had a hard decision to make of, could we make a jump to leverage what was becoming, by far the predominant technology of the day, CMOS, which we had experience with from our low-end mid-range teams, our team in Birmingham, our processor development team there, had great experience in very, refined yet simple designs for systems of this type implemented in CMOS. But could we make that transition? Could we make the jump from one to the other, where we would have to go back in performance capability for a while? We would have to look at reducing certain reliability, availability characteristics, we thought. And when we had clients who were still very dependent on very large engines in order to be able to do that. Or was this a case of the mainframe has run its course, this platform has run its course? Should PCs and mid-range and RISC systems, should they take over, this entire space? Are they better positioned to be able to do it? And, because of my job at the time as the assistant to the lab director, as we were going through this transition in the early 90s, I was in a lot of meetings, just sitting there listening to the decision-making process that faced Nick D'Onofrio, who ran the business at this time, Linda Sanford, who headed up all the software development efforts, operating system-wide, etc., for our platform, and Jerry Granito, who ran all the hardware development organizations for it. And it was fascinating, and we don't have enough time for me to take the time to go through all the different machinations of it. But it really was, hard considerations about do we stop? And one of the things that Nick said, which has stuck with me throughout the career, he said, "Look, these machines are so critical to business, used in finance, in government, in industry, travel, so many different places." He says, IBM has a moral responsibility to make one more generation of mainframes than the industry wants to consume. And that was the path we went on, to be able to do that. So the journey we needed to go through was to get many of these thermal conduction modules and have a roadmap of capabilities to replace it with, technology on the right, which was one of the first implementations that we had, our first generation, the squadrons development coming out of principally leadership on this design was out of Birmingham, some teaming and involvements with Endicott, New York. And this is what faced us. At the time we had a bipolar capability of around 450 MIPS. Yes, this large thermal conduction module, energy guzzling machine that we were going to replace with CMOS. And we're sitting in 1994 with something around a 60 MIP capability. And so parallel sysplex and clustering and development activities to allow applications to be able to operate in these environments was as critical as the hardware on which it ran was, because we had to find ways to be able to cluster and scale and grow in order to satisfy some of the requirements of the workloads. Not all, but some. It was also critical that this roadmap that we started telling our clients about, that on an annual basis, we were going to make this progression through that migration of CMOS-related platform designs. It was absolutely critical we hit every single one on time and on the mark for performance, because clients were laying in plans. Clients who wanted to go with us were laying in plans for this to happen. And that was the cadence. That was what we projected to do. And we were going to make that crossover with the fourth generation in 1997. That was our target, to do that. And then with the G5 or Symphony program, we were going to get, and our target was 700 MIPS at that time for Symphony. And some clients, they stayed with us in certain aspects, but some clients were not able to completely stay with us. The financial industry, Wall Street in particular, almost every client ended up deploying Hitachi Skyline processors. which had something called bi-CMOS, bipolar and CMOS together, bipolar drivers on the edges of chips and CMOS for better power management within the chip, that, you know, had 60 MIP single uni processors. And because of some of the batch requirements at the time, CA's product Datacom, there was a lot of Datacom that was at play in financial institutions at that time. Datacom needed heavy lifting unis in order to be able to do this. So Hitachi really made a lot of progress during this period with those clients, but we were determined to get to that 1997 G4 point, and then see what we could do to make that reverse back to us and to our technology. And we did it. The team, all the way through, operating system requirements, software, sysplex, clustering improvements, the raw technologies and design. And it is one of the moments we still talk about in the lab that's defined a part of the culture around this platform, where we now take such pride in making sure that we hit the dates that we outline, and it carries through to today. And some of this, you know, it's healthy sometimes to be paranoid, particularly when you're in a technology industry. And that coming in at that time is again a piece of the culture that's remained within the lab, for which you know, for which I'm really, really proud to see how all that's gone on. But most importantly, to the clients, clients who looked at this and said, I'm with you, IBM. I'm going with you on this journey, this platform, and the technology investment I have in it, the nature of you, your people, your partners in the ecosystem. That was something that was so incredible to see them do that. And we ran through this various, you know, design techniques, tweaking chip cycle times. In the case of G4, we managed to go beyond the bipolar machine capabilities a little bit, just get up to it. But there's an interesting story. We actually had a little bit of a scare at that point. Because we were a little bit short, we tweaked the semiconductors, we tweaked everything, tweaked code as much as we could, but we were short of our goal by about, as I recall, 25, 30 MIPS. And that's where, because these CMOS machines were fundamentally, you know, air cooled. Prior to this, we got away from the internal liquid cooling aspects of thermal conduction modules. And that's where our closed loop cooling systems got reintroduced. The team responsible for that did it in about 3 months. You know, got that sort of refrigeration compressor technology, got everything running, and it was that cooling the chips a little bit that allowed the technology to run fast enough in order to be able to cross that barrier. Then we went on with the G5, which you know, I happen to be directly associated with as the development program manager, Eric Bayer. If some of you know Eric, you know, originally out of Birmingham, to come over to Poughkeepsie to advance his career here. He was the overall program manager with the business marketing responsibilities as well. And that program with, you know, so many engineers and experts underneath, really became a wonderful program that really set the history of bipolar to the history books. And, you know, we were really running and moving quickly again from an overall growth capability standpoint. Instead of a 700 MIP machine, it ended up being over 1,000 because of what the developers, the processor developers, the cache designers, the memory subsystem, the firmware, you know, operating system, software effects, everything coming together to really hit it out of the park. And then in 1999, we followed up by tweaking that design and adding more processors to it to create the final one in this line, the G6, the Opera machine. We'd actually intended to have 64 bits come in 1999, but that proved to be such a difficult proposition. We did this little swizzle of bringing in this 12-way and goosing the chips a bit, get some performance, and then held off for what was now to become the the year 2000 efforts. The results of this, were really, really superb. So everyone involved with that, and for the client sticking with us, really a great moment. Really showed how critical and what a wonderful technology Sysplex is. We had the largest mainframe ramp up we'd ever had in history to that point, 1,000 systems that were shipped out to clients in less than 100 days. And the nature of that roadmap, it meant that, the BiCMOS, that still had some of the issues of the old bipolar technology, and the amount of investment required in order to be able to make the transition that we had just gone through. Hitachi and Amdahl decided that they were not going to design new machines. They essentially decided to leave the space because they did not see perhaps that this platform would continue to be what it is today, whatever the choices were. But that's when we then got into partnerships with Hitachi, where they would use our chip technologies and use them as part of their systems for their clients who are on this sort of architecture within their marketplaces. And we then started to focus on the growing enterprise computing trend that was starting to emerge. And really, this is the marriage of this platform along with mid-range power systems, intermediate tiers of architecture, and obviously personal computers and edge computing. That was a very big focus of 1998. And in IBM's annual report, said I promise I'm not bragging, but I got to have my photo stuck in there for some reason. I sometimes look at it and I see more Basil Fawlty in there than I do myself. But there you go. But this whole report was really starting to focus around the bringing together of some of the themes of the swings of the mainframe is dead, and that was starting to really peter out, and the linking of all the different elements together in a true enterprise infrastructure class was where the focus is. And that was the theme that we had associated with this report of keeping things flexible, keeping things small, and building things through. During the period that we were working through with the CMOS transition, we also completely transformed the way in which development was done within IBM. In '93, Lou Gerstner came in the first time someone came in from the outside of IBM in order to take the helm. John Akers retired from IBM, and that made that transition. And if someone else was brought in order to really take a fresh and a critical look at what was going on within the company because of those economic effects and because of the costs and the nature of the development profiles. And one of the things that Gerstner first did was he put together a number of re-engineering initiatives, looking at go-to-market, overall expense natures, things like that. And one of the programs is associated with development. And I was the mainframe representative, if you will, as a part of that re-engineering effort that really was intended to transform how do we do development, implementation of more rigid stage gate processing, better concepts and decision about what is done. And that was a very critical part as well of really helping us get on a track of making and hitting the dates that were so essential for that. When we went and made that migration through into that whole particular platform, one of the things that we saw from it was a whole new class of availability and reliability just because there were so few components, because of the density of CMOS that was capable there. So it really set us up for excellent progress in the 2000 timeframe. We hit the 2000s and Y2K, all the effort leading up to it, big fizzle as we turn the clock, and enough said of that. So in 2000, Lou was still the chairman and CEO. In another couple of years or so, I think it was, Sam, who was president and chief operating officer, moved up and took over. And you can see that the employee numbers have shrunk quite a bit. And that was because of some of the restructuring and the host of things going on in the 90s that really had a large effect in a number of areas. The revenue, things had bounced up and moved, and IBM was certainly looking quite healthy at that particular time. And from a technology standpoint, eServer, P series, I series, and Z series, that was first announced there in 2000, and Z series, obviously, many people still refer to our platform today as that. The R6000 SP system, which was a commercial application of supercomputing technology we put together with our RISC capabilities for something called ASCII White with Lawrence Livermore. And we also announced a huge investment in upgrading and advancing the semiconductor facilities down in Fishkill, New York, $5 billion to be invested over the years, because as you move up in larger size wafers and as you move lithography densities and all of the beam technology, the money associated with staying in that is hugely expensive. And this was really, the last sort of major investment that I recall. Obviously, there were others and subsequent to this, but from a magnitude standpoint, that kind of spending is really why today, IBM partners with what was Global Foundries for a while, now partnered with Samsung, so that as many industry people do, so we can all leverage one common set of semiconductor foundry capabilities, but still retain a lot of the intellectual property of all of it from a design standpoint, device physics, how those things are best used, because that frees up, a lot of this money for use elsewhere. And if you're a PC person, NetVista, I remember I had one of those as well. In 2000, that was where 64-bit came in. The IBM Z900, and then subsequently 800, was a huge effort. Z900 was released just at the last few days of 2000, actually in December, and really started being picked up and deployed by clients later in the first quarter of 2001. Huge design efforts involved, but also that 64-bit implementation, the work that was going on around enterprise IT, we were really able to leverage there all the work that had been going on really as somewhat of a skunk works, a behind the scenes kind of effort over in Birmingham. The Birmingham team involved with this were just absolutely brilliant. Rather than trying to go through any formal review process, they worked on all this, and then one day, as the story was told to me, I was not there for this one, I believe it was General Manager Dave Carlucci at the time was over in Birmingham, and they just took the opportunity to show it to him, and he loved it, and the rest is history, and thank God so, because that really started the launch of Linux on the platform 20 years in now, and a vital and really important part of this platform. Not only as it grew over the time because of this notion of enterprise infrastructure and co-location of applications, bringing it closer to data, but now today being such a fundamental part of our presence in the cloud and cloud native related applications. Besides all this development work and all the things that were going through the 2000s, what was one of the great things for me was just the nature of the way in which the development team worldwide really grew together and became truly integrated. when we were initially starting our CMOS journey, we had a Poughkeepsie development team that had been doing the high-end bipolar processors. We had teams in Endicott and Birmingham that had been doing these mid-range CMOS-based designs. And early on, a lot of the discussions, they really were quite head-to-head about, which team would design which processor, who would prevail, who would be the last man standing as a part of developing the CMOS roadmap. But Nick D'Onofrio knew that the two teams between the Endicott Birmingham team and the Poughkeepsie team, and of course, scattered elements in other places, that these teams, every, team had critical members essential to this. So he basically set us up structurally that everyone needed the others in order to succeed and execute this roadmap we went on. But it was in 2000 and beyond, from my standpoint, as we organized, put people together, that really brought the teams together very, very well. So we did a lot of this. And this is one of the things I'm going to remember so much about, 2000 and even in the 2010 period, is meeting and developing friendships and working more and more with people in different parts of the world. Folks around that table, besides the dodgy looking character on the left, from Birmingham Lab, from Rochester, Austin, Texas, all coming together and working together in that way, in that platform. And besides the work, becoming really, really great friends. So 2010, getting closer now. SpaceX and Deepwater Horizon, the 2008 financial crash, still being felt. IBM in 2010. The number of employees had risen quite extensively at this point. There was a lot of things going on around acquisition of services business, growth in different areas, even though the more traditional systems related businesses were operating with very much the same sort of teams going on. Some of the software acquisitions that were done, all those things went to drive up the employee counts. And this was getting, pretty much towards the all-time high that IBM has been at, and edging very, very close to the $100 billion of revenue, and significant increases actually in the earnings and margins associated with a lot of what was going on here because of that enterprise computing growth that was coming through the 2000s. We were preparing for our 100th anniversary as a company. Watson, a lot of work was going on around that with research, and was being prepared to hit the 2011 Jeopardy appearance. And still, today, the use of Watson-based technologies and how we're going to use that in our AI-related initiatives across IBM was really defined by and set by this sort of activity. Hardware and software being brought together under one executive in order to try to get and move some of this operational synergy and improve teaming from a directional standpoint. And of course, very much the push really penetrating everything in earnest around cloud computing. We at that time, Z196 and Z114 subsequently, was the product line that we were in. And we were really focusing a lot on the notion of hybrid computing, how best to tie things together. That's where the ZBX came out of this. And perhaps on reflection, it was something, maybe a little ahead of its time. But, we really learned a lot from the ability to have power blades and x86 blades they're in close affinity, and we still have some clients using a few of these. There are a few left, although it was not the overwhelming success from a directional standpoint that we expected. But the things that we learned there, the way in which this is now becoming and being deployed, the way things could be applied to expansions from a Linux standpoint, the way management techniques and thoughts can be applied to how we approach the cloud. You'd be surprised some of the things that were rooted back in that ZBX environment at the time. And what I also observed as we've gone through this journey, because I've spent a lot of time, as many of you know, and would make sense with the job I have had, is spending a lot of time with clients. And I would see things over time, being directly involved in things where migration efforts, a focus on technologies that we're trying to migrate, the whole area around emulation as a viable product for production, some of the things that Hercules, Turbo Hercules, and the issues that we had there. None of that was proving to really be successful. The lift and shift that had been talked about, the death of the platform because of lift and shift to other platforms, it just wasn't paying off. I mean, yes, there are things that move and they should move and they're right to move, and people have to understand those evaluations. But the whole scale demise of the platform, it just wasn't happening. We were continuing to grow. And so much client focus I was observing really did shift to where's the right place for workload, what's the right elements for application modernization, and where does this platform play into that? And that's why, as we've continued through 2010 and on now to where we are in 2020, that's why the platform has continued to evolve, continued to change, and continued to grow in terms of the amount of capacity that's installed and things of this type. And I'll essentially conclude my observations here on this chart. But that's why where we are now in 2020, what is the nature of the platform? What is the nature of things for IBM? It is so much about the cloud and the investments there. You've seen the announcement of this year where our managed infrastructure services and elements of our global technology services business is being formed into a new company to really focus on that as a discipline and a practice and be able to grow that. IBM becomes even more then focused on the cloud, hybrid cloud related elements. And there's plenty of material to read associated with that story. But we in the Z platform have been working across the entire stack in order to be able to develop all the technologies. How do we leverage open source? How do we link in ways to have a unified and uniform developer experience, cloud native development environments, and have a platform that has the most advanced security for those kinds of implementations. The idea of passing data outside of this environment to elsewhere in a hybrid cloud and still retaining control of it with data privacy passports. So, 38 years, the platform going from a 3084 to a Z15 and all of this, what's it going to be like in another 20 years, which some of you will get a chance to observe. It's tough to leave anything like this and let technology go away. I had thought about it actually, and that was part of the genesis of this 38-year conversation. When I was talking to Mark towards the end of last year or early this year, I pretty much determined that it was time for me to leave after 38. But there's so many exciting things going on, and some things that I do, which I can't really talk about, because I think you guys know a lot of them involve certain investigations into technology and other things with other companies. IBM kind of persuaded me to slow down but not stop. So I'm gonna be doing a little bit more of a part-time kind of thing come January. But what that means is I will still have a chance, if we can do this in person in the Celtic Manor in Newport next year. I will still have a chance to be able to say hello to everyone again in person, and we can buy each other a drink and just catch up on maybe what happened in the past 1 year rather than the past 38. So I hope these reflections are of interest and maybe a little bit entertaining for you. I hope it's not too self-indulgent. And with that, I will turn it back to my good friend, Mark Wilson.
Mark, thank you very, very much. Thank you. And I, like everybody else here, is very much looking forward to having that beer with you in Cardiff. Sorry, Newport. Okay. And Marcus has just popped up a message, said Brains SA. I can only think that's a beer, but I don't know.
It is.
Yeah, it is. I thought it might be. But Mark, thank you very much for that. Thanks for kicking off the conference for us. Everybody, I'd love you all just to fill in your feedback for me. But please, tomorrow is when we really get going. So enjoy the evening. Don't have too much to drink, as we would normally do at a GSE conference. Relax and enjoy yourself. Mark, thank you very much. Brilliant as always. And folks, I'll speak to you all tomorrow, but thank you very much, everybody. And thanks again, Mark.
Thanks.
Cheers, mate. Bye.